So this is our third Electrathon update. In the first two videos, you saw us design the frame and design most of the front suspension. What we're going to do today is we're going to finish up the rest of that front suspension by adding an anti-roll bar, and then we're going to create our own custom differential. Now, the whole purpose behind creating that custom differential is so that we can get it lighter than you would typically find. It's different than you'll see most differentials, and you'll see that later in the video. And also later in the video, we'll explain exactly what that anti-roll bar does. So for now, let's get to work.
Got so much weight on my shoulders, enough to knock me out, but I'm still holding the throne. You never know till it's over. So pretty it hurts, just beware of the thorns. You got a glimpse, and you can't resist, luring you in closer. Guess I got a jinx. You want an honest man, but you don't understand. I won't be here when you wake up again. You want an honest man, but you don't understand. I won't be here when you wake up again. Got so much I need to cover. All the lies I lied, been with me for too long. Got a chance to start over. Disguise the man I was, correct what I did wrong. You got a glimpse, and you can't resist, luring you in closer. I guess I got a jinx. You want honest.
So here you can see the completed front suspension. What you just saw me working on was the anti-roll bar. Now the purpose of this is to do exactly what the name says. Keep the car from rolling over. Now, if you think about it, when a car is cornering, one side of the body tips down, which raises the arm up. Now, if you think about it again, this causes the car to be unlevel. Now that's a problem because it can cause it to roll. What we do to combat this is to make sure the two arms move together. How we do this is we have, off the rocker, two spherical rod ends connecting to another rod. On the other side of this rod, we have another spherical rod end, which connects down to another cylinder, which connects to a rod running between two bearings. Now the rods connected to the bearings are welded, so they can't rotate along it. So when this rocker moves down, because the arm's pushing up, it'll move the other rocker down, causing the other arm to move up, causing them to work together. This makes sure that the car won't tip over when we're cornering. Okay, now that Zach's finished work on the anti-roll bar, it's time for me to get to work on the differential.
You think you're getting cold, 'cause you've been acting cold. I'm coming for your soul, I have no mercy for a 9-year-old. What you see in the daytime, they just won't believe. But when the night comes, they'll be tossing in their sleep. They are watching out for me.
Okay, so it's a new day. Last night we had some issues with the universal joints that we didn't want to address. We had initially planned on using what's called double joint universal joints, so that would help us keep the camber nice and even, so it wouldn't fluctuate too much. but unfortunately it wasn't rated for a high enough RPM. As you can see here, it's only rated for 1,000 RPM, which is nowhere near what we need. So we had to come up with a new design. So the new universal joints are rated for 6,000 RPM, which is what the motor will run at. They're right here. So let's get started on the new joints for the design. Okay, so now that we're done with this side of the differential, let's do the other side.
Cause you're everything I hope for. And I hope you can see how much I love you. If all I see is trouble, you can blame it part of me. I'm broken without you. You're a part of me.
Okay, so throughout a majority of the video, you've been seeing me work on the rear differential and the whole rear axle. So I'm now going to explain how exactly this works because it's a very customized design. It's not very typical to what you'll see normally. So to start out, let's go with the split sprocket in the center. Now this is a 41 series sprocket, which is one of the biggest you can get. And for our purposes, it's going to work just fine. And we designed it to be something called a split sprocket. So it's essentially split in two, as you can see right here. And when it's split in two, to mount it, we have 6 bolts. These are 1/4-inch bolts, and this will keep it attached to our customized hub. So now I'm going to switch over to the other side, which has the exploded view. So as you can see, in the hub, we have a large gap, which is a pipe. It's actually 2 pipes, which will be welded together and pushed up against the steel plate. Well, sorry, aluminum plate. And inside these pipes is a sprag clutch. Now, I'm not going to go too in depth on how sprag clutches work. There's a great video on that, which I will link in the description of the video. And so I'm just going to explain how we're using it in this instance. So a sprag clutch is essentially a bearing that rotates only one direction. So one direction it's free flowing, and the other it locks tight. So in our way, it will be free flowing going opposite of the sprocket. So the sprocket will turn forwards this way, and when it's turning that way, when the chain is driving in, the sprag clutch will be locked. So it will be moving with the sprocket, basically simulating a drive. So at that point, we're acting like there's no differential. And as you can see, you might not be able to actually. This is a keyed on outside and inside. So that's how we'll mount it to keep it from rotating inside of this. But back to what I was saying. When it's going forwards, it will be locked tight. And this will simulate a differential being able to move with the axle. However, if weight is applied to one side, the other side will more weight. The other side will then start to lag behind. So this will then start going this way. So reverse on the sprag clutch, and this will be free flowing. So it's not actually moving this wheel out here. Now, what that will do is it'll simulate a differential. So we can then take our turns at the required speeds and still handle properly, because as you know, to take a proper turn, the outer wheel needs to be turning faster than the inner wheel. At least with the 2-wheel car, a 4-wheel car. Most Electrathon vehicles are 3-wheel, so they don't have to do something like this. For our purposes, we want to do 4-wheel so we can have better handling and also be able to take higher speeds without risking that back wheel wobbling. So from the sprag clutch, you can see we have a bearing which mounts flush against it. You can see on this side. And then inside that bearing, it's also keyed. It has a little bit of axle right here. Now that axle mounts all the way inside the sprag clutch, which slots up against the back and pushes back up against in the hub. So it's mounted super far in depth, so it's super secure. And then on the end of that, we have a universal joint. Now the reason it's not just a straight axle coming off the sprag clutch is because we're also adding rear suspension. We are doing just a straight shock absorber mount. And to allow us to do this, we have universal joints which will let the axle move up and down without having to move the sprocket up and down, which will take the chain in and out of tension. So our initial design, as I explained earlier, had a double universal joint, but we had to replace that. So this will actually give us some camber, which is what we want. And finally, we have on the outside here just a bit more axle, which will then mount to our sprocket hub. Now, our wheel hub, which will be seen in next week's video when we finish up that hub, the wheel, and our rear suspension. So that's all.